Do you know where the edge of our solar system really is? Most people think it ends beyond Neptune at the Kuiper Belt. But the solar system is far larger than we might imagine. What if I told you that our entire solar system is surrounded by a vast, invisible shell filled with billions or perhaps even trillions of icy objects? This mysterious region is called the Oort cloud. Today, we're going on a journey to the very edge of our solar system to discover what it is, where it lies, and why it could hold the secrets to our cosmic past. The Oort cloud is an enormous cloud of icy objects surrounding our solar system. Unlike the planets, these objects don't orbit in a flat disk. Instead, they form a huge spherical shell around the sun. Scientists believe it contains billions or possibly trillions of frozen bodies made mostly of ice, rock, methane, ammonia, and dust. Many of these objects are leftovers from the birth of the solar system about 4.6 billion years ago. In other words, the Oort cloud is like a giant frozen time capsule preserving material from the solar system's earliest days. The existence of the Oort cloud was first proposed in 1950 by the Dutch astronomer Jan Oort, after whom it was named. Oort suggested that this vast cloud of icy objects acts as a reservoir of long-period comets. These comets are occasionally disturbed by the gravity of passing stars or the Milky Way, sending them toward the inner solar system, where many are eventually destroyed after repeated close passes by the Sun. However, no direct observational evidence for the existence of the Oort cloud has been found yet. Scientists believe the Oort cloud consists of two main regions. The inner Oort cloud, a denser, disc-shaped region that is thought to lie closer to the Sun and is roughly aligned with the plane of the solar system. The outer Oort cloud, a much larger, nearly spherical shell that surrounds the entire solar system and is believed to be the primary source of most long-period comets. To understand how far away it is, let's compare distances. Earth is 1 astronomical unit from the Sun. Neptune orbits at about 30 astronomical unit. The Kuiper Belt extends to roughly 50 astronomical unit. But the Oort cloud doesn't even begin until around 2000 astronomical unit from the Sun. Its outer edge may stretch as far as 100,000 astronomical unit, or nearly 1.6 light-years away. If a spacecraft traveled at the speed of Voyager 1, it would take hundreds of years just to reach the inner Oort cloud. When the solar system was young, giant planets like Jupiter and Saturn were constantly pulling on smaller icy objects with their powerful gravity. Some objects crashed into planets. Some fell into the Sun. But many were flung far into space. Instead of escaping completely, the Sun's gravity kept them loosely bound. Over billions of years, passing stars and the gravity of our galaxy slowly reshaped these distant objects into a massive spherical cloud. That cloud became the Oort cloud. Here's something surprising. No one has ever directly seen the Oort cloud. It's simply too far away. The objects are incredibly small, dark, and spread across an enormous volume of space. Even our most powerful telescopes cannot clearly detect them. So how do scientists know it exists? Because of long-period comets. These comets appear from every direction in space, suggesting they originate from a giant spherical cloud surrounding the solar system. The Oort cloud is currently the best explanation. Every once in a while, a passing star or the Milky Way slightly disturbs an icy object in the Oort cloud. That tiny gravitational push can send it falling toward the Sun. As it approaches, sunlight heats the ice. The frozen gases turn into vapor, creating the glowing coma and long tail we associate with comets. Many famous long-period comets likely began their journey in the Oort cloud. Some take thousands, some 10,000s, even millions of years to complete a single orbit around the Sun. The Oort cloud plays several important roles. First, it acts as a giant reservoir of long-period comets. Without it, many spectacular comets would never visit the inner solar system. Second, it preserves ancient material from the solar system's formation. Studying these icy objects helps scientists understand how planets formed billions of years ago. Third, it tells us how gravity from nearby stars and the Milky Way influences our solar system over immense periods of time. In many ways, the Oort cloud is like a cosmic history book waiting to be read. Despite being one of the largest structures associated with our solar system, it has never been directly observed. Scientists know it exists mainly because of the behavior of long-period comets. Yet these objects are spread across such an enormous volume of space that the distance between neighboring objects could be tens of millions of kilometers. Another surprising fact is that the total mass of the Oort cloud is probably much smaller than the mass of outer planets. Although it contains an enormous number of objects, they are tiny compared to planets. Even after Voyager 1 leaves the solar system's heliosphere, it will remain inside the Oort cloud for thousands of years before finally escaping the Sun's gravitational influences. This shows just how unimaginably vast our solar system truly is. The Oort cloud is one of the largest known structures connected to our solar system. It's invisible, mostly unexplored, and incredibly distant. Yet it may contain trillions of frozen worlds that have remained unchanged for over 4 billion years. Every long-period comet that lights up our skies may be carrying a tiny piece of that ancient cosmic archive. The Oort cloud reminds us that even at the very edge of our solar system, there are still enormous mysterious waiting to be discovered.